Vanderwood, Director of Digital News Media at Signal Media, which is the official news outlet of AFCEA International. Welcome to another episode of our Disruptive by Design podcast that highlights people in the military information technology world under the age of 40, a group that we call emerging leaders. This is a special episode. At each of AFCEA's major conferences, such as West in San Diego, TechNet Cyber in Baltimore, and TechNet Augusta in Georgia, and at other events, there is a panel dedicated to experts under 40, featuring their views on key topics. In this episode of Disruptive by Design, we are featuring the Emerging Leaders panel from AFCEA's TechNet Cyber Conference in May. The panel spoke about cybersecurity in the age of artificial intelligence. Sarah Yee from Belay Technologies was the moderator, with Matthew Penn, Senior Data Scientist at NVIDIA, and from IntelliGenesis, Adam St. Amour, who is a data expert. Thanks for tuning in and enjoy this episode of Disruptive by Design.
DoD Solutions Architecture at Company, specializing in AI and data analytics. He is a leading expert in the application of GPU-accelerated AI and high-performance data analytics to solve complex cybersecurity challenges in the federal ecosystem. Before joining NVIDIA, Matthew served as the Director of AI and Data Science of Altamira Technologies and as the Lead Data Scientist of Booz Allen Hamilton, where he worked with high-profile clients such as NASA and the U.S. DoD. His academic background includes a master's degree in information systems from Indiana University and a bachelor's degree in aerospace engineering from the University of Central Florida. His extensive experience in data science and AI combined with his impressive track record of success in supporting the government agencies make him a highly sought-after expert in his field. Please join me in welcoming Matthew Penn. Next, we are privileged to have Adam St. Amour, the Chief Data Scientist of IntelliGenesis. Adam has over a decade of experience supporting the government and civilian sectors with AI/ML enabled solutions, and he has both instructed and developed AI/ML capabilities to help analysts find solutions to even the most complex problems. Adam's recent accomplishment was designing the IntelliGenesis flagship AI/ML platform, Neural Nexus, which is a GPU-enhanced smart AI/ML pipeline service that delivers low-code, no-code options for analysts in a domain-agnostic construct. This platform is an impressive feat of innovation that enables analysts to work more efficiently and effectively, allowing them to focus on high-value tasks that require human expertise. With his vast knowledge and experience in AI/ML, Adam is a thought leader in the industry. He has made significant contributions to the field, and his dedication to advancing the technology is inspiring. We are thrilled to have him here with us today to share his insights and expertise. Please join me in welcoming Adam St. Amour. Thank you. All right, so let's get started with the questions. Our first question here is, how can we ensure that our AI-driven cyber defense strategies are focused on the most urgent threats and vulnerabilities? Would you like to start?
Sure, I can start. Hopefully I can make this much closer. I guess first it's worth kind of thinking about the problem that we're dealing with here. The last projection I've seen, there's roughly 1 trillion connected things. So, smartwatches like I have on here, my phone, my computer, things connected to the internet, perhaps Bluetooth devices. We've got, as of April of last year, I think it's the last number I saw was 5 billion internet users. And we're on track to generate about 200 zettabytes of data. So for companies like NVIDIA and those out there, that means that we're creating lots of technologies that people are using, but it also represents an extremely large attack surface. And that's bad news for us. That's good news for the adversary. And this ends up having time implications for breaches, right? Which it's clearly cybersecurity is not a solved problem. Otherwise, we wouldn't be here today. We wouldn't be thinking about things like AI. I think if you're average, it takes roughly 277 days for a breach to be discovered and mitigated. And I think the 3.5, 4.5 million, something in that ballpark as far as costs. That's really bad. So if I'm like the Department of Defense or the U.S. government, it ends up being more than a money problem. We have missions to field, and crippling a mission can sometimes be an even bigger deal. So I think for me, making sure that we're focused on the most important, I guess, threats, etc., is understanding that what we're using right now isn't really working. And then I would ask myself maybe why it's not working. So cyber is one of those fields where the data is coming in extremely fast and furious. So we have data rates that are extremely daunting for anyone in the data engineering community. We've got things measured in gigabits, tens of gigabits, thousands of gigabits, many, many, many gigabits. Data that's extremely unstructured in nature. And what we've tried to do with our techniques up until now, and there are a few exceptions to this, is try to keep up best we can. And we pick some techniques that are fairly fast to compute. Perhaps we have pattern matching based systems. We have known signatures that are, if anything looks like this, it's definitely bad. But we're missing a huge bulk of things, and it's taking us a long time to figure those things out. And then I ask myself, what is artificial intelligence really good at? When I say AI, I mean machine learning systems, deep learning systems, and how can I contrast those from, let's say, rules-based systems? And these machine learning systems are really, really good at extracting contextual information from kind of arbitrary data sets. If I think about ChatGPT, probably every one of us has heard about ChatGPT. Maybe we've used ChatGPT. I'm certainly very impressed by ChatGPT in general, and that just really shows you the type of power that these machine learning systems can have, the types of contextual information that they can extract, and the wide variety of questions that you can ask of these systems. So for me, it's okay. So we have these more sophisticated techniques that we can use today. So we can now think about perhaps modeling things at a higher fidelity, right? Instead of picking anything that's on list 1 through 10 and calling that bad, we can perhaps model our all the tenants on our network, each individually, update those models on a regular basis, detect things like when something's going wrong. Describe why that detection was made, and do this at tremendous scale. So I think this is kind of a key differentiator for AI, and we can use it for things it's good at, right? But if we have, this is an AI panel, but AI is not the solution for everything. I think the right answer is a combination of these classical techniques with these more robust compute techniques based upon artificial intelligence in order to kind of really open up the aperture on our defenses.
Honestly, Matt, Matt and I have known each other for about 1.5 years, so we've worked on some of these panels before and kind of talked to some people about, what is AI, what can NVIDIA do for small businesses specifically, and that's kind of where I come from. But really, primarily, our interest was on collaboration. We wanted to have a partnership with NVIDIA, one, because it opened up the aperture for us, but then we started learning about some of that technology. We tried to figure out, we always talked about near real time when it came to the intelligence community, but what happens when we start enabling real time analysis? And for us at Intelligenesis, that's what we really started trying to broach with NVIDIA. And Matt, I'm pretty sure at this point, every single time I tell you that, hey, I might have hit a stag, he's like, well, I got some code for you. Let me show you these things. And that collaborative atmosphere that is created, especially in these places, really enable these small companies to start providing some of these capabilities to the government, to the consumer market as well. And that's kind of the other part too, is like not being afraid of taking things like hearing words like ChatGPT is going to take over our world. Well, what is it? What are we trying to do to enable this stuff? What are we trying to do to protect ourselves doing that? How are we going to use all of those the zettabytes worth of data that, I think what was it in 2001, all of the data in the world in human history ever existence was probably what happens in less than a minute today. So we're talking about these massive volumes of everything that we have to figure out a way to protect. and how we need to find something in some way to infer that data. And for us, we started talking about this concept of no longer is it really kind of automation or AI enabled stuff. It's augmenting our abilities for our analysts to be able to produce something. So we want to enhance their capabilities and not remove them from the picture, because that's kind of the big first piece that we really want to try to move towards. And that's something that I know you guys at NVIDIA really felt. And, you know, imparting that same thought process for a small business is really big for us too.
Thank you.
I might add just a few additional thoughts on that. So like alert fatigue is kind of a big deal, right? How can we reduce alert fatigue? How can we get the right alerts, right? Like, you know, if I have hundreds of alerts and none of those are right, that's bad. If I get no alerts and I'm missing everything, that's also bad. And if we're leaning on these non-AI based techniques, we're missing the boat here. These most critical threats we're not detecting. So I think finding a way to kind of move those detections further to the left. Let's say we have a bag of 10 alerts. We want to make sure that we've got the right alerts in that 10, right? If I can say an analyst can inspect, let's say 15 alerts a day, I'd like most of those to be worth hunting for, as opposed to pick one from the list, it doesn't work so well. Pick one from the list, it doesn't work so well. By midday your eyes are glossed over, right? I think we can do better, and I think right now, of all time, it's really an exciting time to do better.
Yeah, and honestly, like when it comes to information and all of this stuff, like for the longest time, we had a data problem of not knowing what was going on. Now we have a data problem of knowing too much of what's going on. So we have to kind of figure out that too, and that's kind of where like the utilization and like the buzzwords that we hear about, like GPUs, CPUs, all these different things. That's where those things come into play. Is how can we make these things go faster? And honestly, so far right now, when it comes to GPUs, it's the easiest one for us to do the most amount of work with. And that's kind of the best part for it. And not to mention, a lot of the frameworks that we utilize came from NVIDIA in the first place. And I know I'm not a salesperson for NVIDIA, but I feel like I'm always kind of like screaming their name because of how easy it was for us to integrate into our own technology.
Well, that's music to my ears. We eat a lot of our own dog food, and we put out these bits of software to the ecosystem and hope that like a rising tide raises all ships. So that's just really cool to hear.
Thank you for that. Our next question: what steps can be taken to ensure that AI technologies are properly aligned with the overall cybersecurity objectives of an organization?
Can I take this one first?
Yeah, go ahead.
So this is going to be one that is probably going to anger my own CEO, is we want to make sure that we have rules in place. The biggest thing for us is being able to evaluate and understand what everything is going on is really important, especially when it comes to providing something up that can potentially provide you an answer that might be poor, might be wrong, might be already poisoned with something. So those are ways for us to be able to really need to identify what are we trying to do with it. Not to mention, we want to make sure that we have these core requirements in place so we know, like, hey, this is the technology stack that we're utilizing. This is where it's going. This is how we designed it to be able to enable future operations. This is how we're able to do it today. And we want to have a plan for that, but we also need to we need to have those checks and balances too. So we need to make sure that we have rules and have requirements to be able to identify exactly what we're trying to do too.
I might start with a simple example, probably because I still have blisters on my hands from the other weekend. So around the winter time, for some reason we aggregate lots of stuff in our garage. Right? We get springtime. I feel like a hoarder. I have like this one path where I can kind of get my shoes on and walk out. And so a couple weeks ago, we decided to buy some shelving. And the shelving was going to give us hopefully the opportunity to, instead of putting things on the floor, put things on the shelf, so that when I have my garage open, that my neighbors aren't whispering about me. So when I was going through I promise this will be relevant eventually. So when I was going through the instructions to build this thing, I'm looking at it, and I have tools, right? I have some hardware in there. I've got the little mini screwdriver that's included that never really is good enough. So I go into my toolbox. And I'm looking at each one of my tools in there, and at some point in my, home improvement career, I've bought something. I bought something for a reason, and I think that's really the key here. Is we have a job to do, and the job is to protect our networks. Our job is perhaps to implement zero trust, and we should not be procuring anything without a reason. We should have a reason for everything, every tool in our tool belt. So then I'll direct this now towards, I guess probably more so towards a zero trust discussion. There's been several zero trust strategies that have been published at the federal level. The one I was reading most recently was the DoD zero trust strategy. So I'll just reference that since it's the freshest in my mind. And if I look through the pillars and the sub-bullets of those pillars, and I'm an AI practitioner and I'm building something, or if I'm a vendor with a tool that's going to do something interesting, I would hope that it would line up to what our organization is trying to achieve. And if not, I've got to ask myself some good questions about why I'm making that decision. So if I think about the AI and some of the neural network approaches and how powerful they are, and I mentioned earlier the ability to maybe model every user on a network or every tenant on a network, that's a very powerful idea. And it's like, okay, great. Well, why are you going to do that? How is that going to help us drive forward? And I think my answer would be under the user pillar, there's something called continuous authentication. And if Matt Penn logs into the system at 9 a.m. after he drops his kids off at the bus stop, that's pretty normal for me, right? If I'm logging into supercomputer A followed by supercomputer B followed by my team Microsoft Teams, like that's pretty normal for me. But if I start to do something very different, perhaps I start to look like somebody from the HR department looking at a bunch of employees' PII or something else. That's maybe not so typical for me. Or maybe I am working in strange hours with sharing lots of data when I otherwise wouldn't have been, hitting some external IP address. That's not so normal. And I would want to understand and be able to model those kinds of, at that level of fidelity to detect these kinds of things. And my, specific reason for implementing that kind of anomaly detection AI would be to line up with that kind of specific zero trust pillar. So I think for me, it's making sure that we know why we're doing what we're doing, so that we don't waste time, and make sure we maximize the effect. So I think lining up with the requirements and then refining those requirements, right? We're going to discover things as we go through this journey that we didn't know before, and then when we do that, we're going to refine our position and our understanding of the problem, and then we're going to try to solve for something new. And I think it's just making sure that we're aligned to those North Stars as much as we can be.
Thank you. Our next question: what challenges do organizations face in implementing AI-driven cyber defense solutions, and how can these challenges be addressed? Would you like to go first? Yeah.
Many challenges. Where do I begin? Let's see. So neural networks were first dreamed up. They were first proposed in 1944. This is not a new idea. 1944. They weren't necessarily made practical until 2012. So that's 68 years. And one of the reasons why they weren't practical is because the hardware didn't necessarily exist to do that kind of thing. It was really interesting in a scientific publication or a paper, or maybe a applied mathematics graduate school course where we're exploring this idea, but not really anything that we can think about practically, and definitely not anything we can consider for cybersecurity, especially with those data rates I was talking about that keep me up at night. So I think understanding the type of problem that AI and cyber implies is, I think, it isn't really internalized by a lot of folks. Right? There are a lot of dependencies to be successful. This isn't just open up a Word document. This isn't just apply a regular expression. These are, arbitrarily complex mathematical models with a lot of floating point operations that couldn't literally have been done until just over a decade ago on Earth, and that's only because the hardware was there. So it's one thing to kind of go to a conference and hear about AI, and another thing to be a practitioner of it. So there's an example many years ago where I was a data scientist on a program. And I was responsible for doing some very, fancy modeling. And, my first couple weeks on the job, I was given a Department of Defense laptop right here, and I was given a big pile of hard drives right there, encrypted hard drives, and I was asked to go ahead explore this data and come up with some insights and use some AI. And I'm looking at this and I'm like, rubbing my head a little bit. I'm like, well, like, I can't plug these into this, number one. Number two, I can't install any software on here. And number three, I have like 4 gigs of RAM. And number four, I can't access the cloud. You don't have a compute cluster. Where am I going to upload this? Just the questions unraveling and unraveling and unraveling. And I think it was a really important experience for me, because I have an appreciation of where things can really start from the ground up. And I think probably more importantly for the organization that I was collaborating with. By asking those questions, we had to really understand what it took in order to become a data-driven organization, an AI-enabled organization, so that these techniques could be applied towards, general purpose, organizational data problems as well as cybersecurity problems. So I think, one of the biggest challenges up front is understanding the dependencies of saying, hey, I want to endeavor on this AI journey. Now, the other piece is skills, right? Skills is a challenge, right? There are people with PhDs and this and masters in that, and sometimes you've got to go to war with the team you've got, right? And especially in cybersecurity, we have a fixed set of human resources that are really strong domain experts, and maybe they're not necessarily data experts, and then maybe I have some data experts that are not necessarily cyber experts. And it's really, really challenging at times to find the intersection of those two in a single person. So I think right now with these large language models like ChatGPT or these large transformer models, we're at an interesting time where we can provide some technical capability to these folks that may not have gone through the NVIDIA School of Hard Knocks and accelerated computing to just communicate with a system in human language and have it perhaps drum up a prototype for an automation pipeline that's working on your enterprise data sets and kind of get started from there, or just describe it in human terms, kind of the effect that you want to have from this software program that you're actually not typing software for. One of the examples of this, one of my colleagues was messing around with one of these large language models, and he wanted to pull data from an API source, and he wanted to look for something in this kind of data set, and then he wanted, if something was above the line, he wanted to send an email alert out. And he did all of this by just literally typing prompts into the terminal or into the little prompt interface, got out some code. He was actually a developer, so it was nice for him to be able to validate it, and he actually realized I didn't want to use this library, I want to use this library. So he swapped that out, and they deployed that thing. So that's just, while it was a technical person, it represents a capability that just didn't exist a few months ago. So if I think about the skills gap that's persisted for, probably almost every large conference keynote I've attended for the last 10 years or so, this is an interesting time to take a new kind of stab at that problem.
That's well said, Matt. So, and honestly, the other big thing, too, that we started seeing is approaching this from a way for people to be able to understand. One of the things that was really important that I've talked to Matt a little bit about is how do we bring in people into this crazy world of applied mathematics, people who might have been programmers or software developers, people who might have been computer hackers and scripters. We have to figure out a way to be able to do that. So applying methodologies, especially ones where we can approach this topic from a way of trying to help people understand. And it kind of goes back to the same language piece. And that's kind of the whole issue when it comes to cybersecurity with AI and machine learning is we have a ton of different tools and capabilities that provide us amazing insight into our networks, allows us to counter adversaries in these, air gap systems and stuff like that. But ultimately what we really need to have is we need to have the analyst. And that's something that we've lost quite a bit. There's projects going on right now that we work specifically to try to help train and equip people to be able to do this exact thing. So in order for us to start doing it, we started to have to ask a question like, how can we provide some sort of interface for somebody to use that could potentially provide some sort of machine learning capability that provides some level of inference? And that's honestly one of the only reasons why we really added in a low-code, no-code option for one of our products. It's because we wanted to enable the person who just came out of a JCAC, somebody who just came out of their tech school or their A school, to be able to utilize some of these things in a knowledgeable way, so they can start understanding those things. Because Matt laughs once in a while, but I'm definitely not the mathematician of the two of us. sometimes I have some difficulties with those things, but I come from the background of being one of those people that worked in this environment for so very long that I grew this expertise that I didn't necessarily know I had. I learned how to program, I learned how to apply these things, and then I was lucky enough to be able to team up with data scientists to really figure out how to enable these systems and then learn what is important to them. So I think that's kind of the other big part from my perspective too, and that you highlighted, was we need to approach this from the fact that, unfortunately the commercial market has all of the talent currently. The government needs to start utilizing and tapping into that piece, and that's kind of the difficult part between the two, is how do we broach that subject and that topic between the two of them, and then apply something like cybersecurity that's always been a complex issue, and apply those tools and methodologies that we can use and enable them with AI and machine learning too.
Yeah, I think combining the technical teams with the analytical teams, those two groups are not necessarily mutually exclusive. But combining those two and letting the analytical teams perhaps help drive the technology to its position so that it's the most relevant. I mean, it ties a lot to the previous question we just talked about. Helps us refine what it is that we're trying to do in the first place. In prior lives, I was on teams that were much like that. And I like to tell my wife I was like the Q in James Bond, where I'd come up with this widget, right, and I would give it to somebody who was doing something much fancier or sexier than what I was doing. I was just a nerd guy in the Mac room. But I would come up with this like really, really cool new thing, right? And I came up with this new cool thing not because it was intellectually stimulating or went really fast, but I did it because the analytical team had a very specific need and they had a very specific time crunch. And they gave me the requirement, and I built something that helped solve that requirement, and then we scaled that thing to solve for that requirement for everyone else. So I think that fusion of those two teams is an important piece.
Yeah, and I mean, honestly, especially when it comes to a lot of the newer generation, they come up with really cool ideas that we would have never even thought of too. So, like, even though we're both under 40, the people who are under 30 at this point are actually coming up with great things. Like, I think just as an example for cybersecurity, one of my analysts came up with a model that was originally designed after looking at taxi cabs in New York City to figure out where parties were. And he applied it to cybersecurity and found all of his anomalies in his traffic as he was trying to identify it. And utilizing that thought process of going, hey, well, what if? What else could I do with this? Where could I go with this? That's what really starts enhancing and enabling us to do some of these great and amazing things.
Thank you. Our next question: what role can AI play in improving the readiness of cyber defense teams to respond to emerging threats? Do you want to?
Yeah, sure. First of all, I think it could play a huge role, assuming that you've thought through the dependencies of this massive endeavor that we're taking on. So if we solve for that piece, one of the exercises I like to do is like, what would I do if I had unlimited compute? Like, we just take that off the table, assume that somebody's thought about that, and I can go in and somebody's not going to issue me a DoD laptop. I'm going to go in and actually have a proper computing system. What would I do? And I would leverage AI in order to bring that time to detection and mitigation to the left from 277 days. And how I would do that is perhaps I would, instead of querying some database of known threats, what I might do is I might leverage neural networks to detect zero-day threats. And I would do that by looking at what are the normal types of things on behaviors on my network, and I would use that to inform a contextually rich model that would then thereby be used to perhaps look at every single packet or piece of net flow or combined kind of data set flowing across my network, and I would do that. Perhaps I would detect things like lateral movement using things more than heuristics. Perhaps instead of looking at just one packet at a time, or instead of just looking at one net flow at a time, I'm going to look at the entire graph at a time. And I'm going to run graph-wide calculations very often per day, and I'm going to observe the dynamic change of these relationships between these nodes on my network, right? Perhaps I'm going to literally train a model for every person in the DoD and understand when they start to look like an insider threat. Perhaps I'm going to throw a transformer model and inspect the most difficult part of the packet, layer 7. It's fundamentally unstructured, right? And I'm not going to throw a regular expression at it. I'm going to throw a transformer model, and I'm going to look for these subtleties. And then I'm going to index this data into my favorite database so that it's exposed to with some interface that my analytical team likes. And I'm going to enable them to query by Boolean instead of thinking about what's the right pattern to write in this interface to find the subset of packets that fit this pattern. Right? Show me every time I sent something that looked like a credential across my network, non-encrypted traffic, and every node that it went to, without having to think about what the pattern matching system looked like. Perhaps I'm going to use a large language model to encode or create an embedding. This is a technical term, which numbers that have contextually rich meaning, so that I can semantically search this data. Show me every event that looks a little bit like this. Right? I don't know how I would do that otherwise, but now with these large models and this AI, I can do these kinds of things. Right? And I can put these capabilities in the fingertips of our analytical teams. Our SOC teams can now do that. So that's what I would do in order to achieve those goals.
That's a great answer. So one of the big things is that as we're kind of moving into, it's like, for the longest time we've been asking Siri for help or asking Google, but now we're asking ChatGPT for help. So what does that mean for a cybersecurity analyst? Can we pre-train a model and then train it on 50,000 different phrases to say, hey, these are the ways that we would identify this type of information in a potential breach? Will it provide us the correct answer for us? What happens if we start doing things like that, plus adding it onto a flyaway kit that can do real-time inference and start finding and addressing these problems? The problem that we ran into for the longest time was like the availability of some of this technology and then the acceptable nature of each one of them. Like we're putting in A100 cards onto flyaway kits now because we want to do real-time analysis on different field sites. These are the types of things that we had to have been talking about, and now thankfully we're talking about these today because a lot of our cyber protection teams really need these capabilities to help enable them to be able to do their job. That supported with some of the ways to be able to do, don't be afraid of large language models. Enable them, but enable them in a way that are going to maximize your use cases. Be specific about them. You don't have to ask, the 127 billion parameter, GPT 3.5 where all your data is going to the internet somewhere. Ask something that's built on your own infrastructure, that's not tapped out to the internet, that you can help train. Once you train that, then you can enable your analyst that's going downrange or trying to identify a breach and have it provide something that is augmenting its support, so it knows it's not alone trying to figure out where a breach might have happened, what was going on, where a problem might be addressed, or maybe even there was just like a network connectivity issue. So you can start looking at all of these issues in different ways and start applying specific AI modeling to each one of those, but do it in a way that's going to help and enhance and not necessarily just be another buzzword. And that's kind of the problem we ran into, is we started having these really cool deep learning methodologies and large language models, but at the end of the day, what we're trying to do is we're trying to address a problem, which is we need manpower to be able to enable our analysts to do something, and especially when it comes to protecting all of that data, we have to figure out a way, and we have to figure out a way quicker than not.
So you said something that made me laugh inside a little bit. Asking my question to an open internet endpoint, large language model, getting an answer. And you mean to say an organization might actually want their own language model and they don't want the answer from Reddit?
Right.
But anyway, I think that's an important point, right? So these capabilities are super available. You said another thing that really kind of struck home for me. Is you said flyaway kit. I don't know if everyone here knows what that means. It's kind of an edge computing device that comes with pretty efficient hardware in a box kind of thing. I think that I'm going to abstract up a little bit. That represents a scenario where you may not have internet connectivity and you still have defensive cybersecurity goals. And what that means is if I have a modern AI or heavyweight compute technique, I can't use it there, right, in traditional sense. So what would you do? You'd be like, okay, well, I'm just going to be okay with lesser defenses I have there, and then maybe I'll get around to it at some point when I can connect this data back to the central level. What's available today is the ability to outfit some of these boxes with heavier weight compute, which means you can run those workloads that you would have needed the cloud to do when you're in a DDIL environment, which is like super crazy to me to even think about. But that's just, we can bring lots of these techniques to the edge now where it wasn't always a possibility. And if you think about, those dependencies, always go back to that, because if I'm on the hook to make a birthday cake for my son's birthday, I better have all the ingredients, otherwise he's going to be really sad on his birthday morning. So anyway.
And honestly, it's a big thing too with Pendulum, because with a great reward comes great risk, or whatever the Spider-Man quote is. I'm terrible at quotes, but like that's the other part too. Is like we have to be able and be cognizant of what we're trying to do here. Is there a reason for us to put AI or machine learning algorithms in its correct spot? Is there a spot for it to even happen? Most of the time right now is we're saying yes because we need to be able to affect that data, or we need to be able to find some level of interest in that data. So on the flip side, it's going, hey, let's be cognizant and be careful at the same time. We want to be able to create, the cybersecurity analyst that's the Green Beret that can go out into the woods and then somehow there's an entire city. But we have to be smart about it, we have to be tactical about it, and we have to enable them as they're starting to grow. And as these technologies are moving, because we want to make sure that we don't affect things like data poisoning and some of the other things that could potentially be of issue too, that we just need to make sure that we address those things too, because great reward, great success, and then there could also be a lot of risk too. So that's kind of where the other two questions come back to, is like we want to be cognizant of the rules and the requirements, as well as enabling the analysts on the flip side too.
Thank you. The next question: how can organizations stay ahead of the constantly evolving cyber threat landscape by leveraging AI technologies? Do you want to?
I can take a stab. We might go ping pong on this one.
I think so.
So I think attending conferences like this is a big step in the right direction. You're going to hear about, you're going to hear from people like us. You're going to, walk through and see walk through the exhibit hall. You're going to see some vendors who, are some of which are likely building on some of these ideas we've talked about here. I think ultimately the best way is to get started. And I kind of go back to that example. You don't know what it takes to get to your end destination until you start taking a few steps. This is a rapidly evolving field. There are many capabilities that are available today to get started in order to close those gaps. So I think just kind of getting started is kind of the biggest thing. And once you do that, you'll be guided by those requirements, or those perhaps zero trust pillars, and you're going to be getting started with the end in mind. You're not just going to get started, training a cat detector for cyber. That's not really going to do you any good unless there's some crazy news that I'm not aware of. It's based on hot dog, not hot dog, for the viewers the show Silicon Valley. Just a little shout out there. But I think that's the best way, right? You've got to get started, and you're gonna learn the path as you go along.
Yeah, and honestly, the other big thing too is like, this is me coming from a small business saying co-opetition, or whatever we want to call like competition with cooperation. It's extremely necessary. There's plenty of business for everybody. Government-wise, you guys really need to address the idea of going, we want to have the best in breed for all of these things, and the best way to do that is exactly by choosing the correct person for the correct answer. And that's kind of what we're trying to do here, and what we're trying to address is going, hey, analysts don't want a new tool. Analysts don't want something that's going to be completely different than what they understand. But we want to be able to address some of these new things that they need to be able to do with the data. So we want them to be able to have the best thing. But on the flip side, we want to make sure that cooperation, especially among peers and some of these other companies, is there's plenty of business for everybody to do. That's the one thing that we don't have a problem with, is similar to the data problem. There's way too many problems that need to be addressed. So how can we effectively manage those things and be able to achieve some really good successes, especially when it comes to that cooperation between both people like, for instance, my company chose to be a partner with NVIDIA, and one of the big things that we really tried to do was we wanted to have them help us understand why we want to move to the next things. And that's the big thing that like Matt and his team of analysts and his data scientists have really helped showcase to us, is it provided us the way to be able to move forward in ways that we never even would have thought to. We started throwing GPUs into problems that we didn't necessarily think that we needed, and then we figured out that there was also a compute issue, and that allowed us to start achieving even more results. And if we didn't have that partnership and that cooperation on that piece, we wouldn't have been able to address some of the other cybersecurity problems that we had, some of the other functions and other tools that we were trying to design. So it allowed us the way to employ these technologies in a really awesome manner. And then teaming up with like the people like Ceiling Tech and stuff like that, having them give us some of their hardware to address and to play on, allowed us to be able to get that hands-on experience that we could turn around and say, hey, you guys are going out for a flyway kit. We also know how to be able to provide the service. Ceiling Tech could provide the hardware, NVIDIA could provide some of the additional support and some of the GPUs involved, and that's kind of how all of these things are starting to come together, and that's what's really important, at least from my perspective, is going, I want to make sure that our analysts at the end of the day have something that they want to use and something that's going to actually help them and not necessarily harm or take away from their job just because there might be a buzzword or two in there.
Another interesting thing is, so as an organization becomes more mature in their kind of AI-enabled cybersecurity defense, chances are they start to build some capabilities that they want to keep proprietary. Right? They don't want to release how they're able to detect these things because they don't want somebody to exploit that. And then, you know, as time goes on, they start to have a huge repository of this, I guess you can call it intellectual property, for which they're going to deploy towards a whole bunch of different, you know, evolving threats. Perhaps these organizations are the only ones in the world that know how to defend against these kinds of things. Taking these capabilities and deploying them typically means, and depending on where you engage in the software stack or supported software product, you tend to have data pipelines fundamentally. And if I want to use capability A, there are several elements of that data pipeline that I'm going to have somebody build out for me. And chances are, you're going to have another one. You're going to have another data pipeline. And if you look at these two things, you're going to start to see some commonalities between those. And you start to have a nice repository of data processing modules for which you can really kind of land and expand on your defensive, kind of AI-enabled defensive journey. You can really start to, you know, take on more complicated tasks as you start to, with each step you take, you kind of have this combinatoric effect of the new things that you can take on because of these new capabilities that you've harvested and thrown into the repository. We've seen lots of folks across kind of the government contracting industrial base and commercial industry taking this exact approach and are surprised how fast that they can move on to new different tasks. I know internally at NVIDIA some of the research that we've done is in obviously language models and deploying these things at scale. But using some of those components, we were able to use large language models in order to train a very, very good spear phishing detector by generating more plausible examples and boosting accuracy by 20%. We didn't have to write that much new code to do that because we're kind of sitting on this body of work. So I think that's really interesting. And that specific example in generating more plausible training data sets also implies that the adversary is probably going to take advantage of these techniques. So the longer we wait to start adopting these, the larger our blind spots become. So we need to start using these in order to protect ourselves. That spear phishing example in particular is one that we've done, demonstrated that, hey, we can actually boost our performance by, 20% in accuracy. That's pretty significant in the AI space. Yeah.
Thank you. That actually concludes all my questions. I'm going to close up and then open the floor up to any questions you guys might have. Thank you all for coming out and attending our panel discussion on the latest development of AI for cybersecurity. It's been a pleasure to hear from our panel of experts and how AI is being used to enhance threat intelligence, automate threat detection and response, and streamline incident response processes. We hope that this discussion has provided you with valuable insights into the current state of AI for cybersecurity and the key trends and technologies that will shape the future of this critical field. Our aim was to equip you with the knowledge and tools needed to build more focused, aligned, and ready cybersecurity operations. As we all know, cyber threats continue to proliferate and grow in complexity, and organizations face an urgent need to ensure that their defenses are focused, aligned, and ready to respond. AI is rapidly emerging as a powerful tool for enhancing cybersecurity operations, enabling organizations to proactively detect and respond to threats in real time. We thank our panelists for sharing their expertise and insights with us, and we thank all of you for attending this event. Let's continue to stay informed and prepared to face the ever-evolving challenges of cybersecurity. Thank you.
So the panel is not actually over. The panel is not over. We're just opening it up to the floor for questions.
Yes, opening it up the floor.
So can we have a first question? We have a microphone there. Anybody would like to come up? I can tell you it needs to be 1 hour to qualify for continuing education. So if we finish first, we can't scan anybody because that's the requirement by CompTIA. So can we get this microphone up in the middle here? Here we go. Brandon.
Thanks, Tina. Thank you both for speaking. Earlier in the conversation, you mentioned ingredients to make the cake. Can you comment a little bit further on what maybe data immature organization needs to do to prepare themselves to be able to integrate these AI tools in a more effective manner in the near future?
Sure. Yeah, that's a really good question. So there's a couple things. Data is necessary, and depending on the types of models that you need to train, you need different kinds of data. Annotated data is typically really nice for supervised learning problems. If I want to detect this kind of thing, or I want to perform this kind of parsing of my logs, or I want to perform this kind of...
I think the new microphone is working now.
If you wanted to classify a unstructured sequence as looking like this or something else, you probably would want an annotated data set. So you would want some kind of capability to take data that's probably images, unstructured text, audio, video, and be able to apply kind of human labels to that. You would want your hardware environment. If you're doing AI, you probably want a cluster of GPUs in order to train neural network models. I kind of remind you of they didn't really become practical until 2012, but were proposed for the first time in 1944. So that's just hardware, but hardware doesn't get you anything unless you're going on a windy picnic. You can put a nice GPU on top of your papers and they won't blow away, but you need to program these things at some point. So you need to have a supported kind of distributed computing environment that includes drivers and libraries and software development kits that perhaps you manage in a cloud native way. You probably want some. There are vendors out there to provide this kind of thing, but you want to include the hardware and software and management infrastructure so that you can train things like large language models across many nodes, so that you can have many different data scientists trying different experiments at the same time. You also want to have an environment that's designed to scale out inference. So that's the act of using this model in production. So if I want to detect a leaked credential in PCAP, I'm going to send that to an inference engine, and I need to be able to handle that distributed load. Those are some of the main pieces that you would probably need. You would probably need your software vendor, whoever your vendor of choice is, to be able to target that kind of hardware. It doesn't do you any good to have a single-threaded code, try to take advantage of, 1,000-node GPU cluster if it's not parallel aware. Those are some of the kinds of things that I would think about. None of those things I had in my example. I literally had to procure a cluster of GPU compute and high core count CPUs. I had to lay down the OS. I had to lay down distributed compute. I had to lay down the drivers. I had to lay down all these things, and then I had to move the data into there. And I did that in a disconnected way, so that every time I had to refresh that environment. There was a lot of pain and suffering involved. So you probably want to think about your process for moving your updated software into this compute environment. That's probably going to be different depending on if it's on a IL2 environment versus some kind of sensitive compute environment. So all of those pieces are some of those fundamentals that before you get started. Not to paint a daunting picture, but
And honestly, that's a pretty complete, like, specific answer. So to really kind of address that too is like we're really looking at the idea of what's the end state? What type of answer do you need to have your industry be able to answer? What types of items are you going to have? What type of data are you going to have to be able to utilize and to pre-process? So these are all parts of like we used to call it the data science pipeline or the data science cycle, where there are 4 different core steps to be able to achieve these things. But really, they follow similar approaches to like what the military used in joint targeting. What's the commander's end state? What are we trying to do here to really answer a question, and then how are we going to be able to do it? So one of the ways that we utilized it, specifically at Intelligenesis, is we started really small. We started with regular processors, regular CPUs, regular environments, started moving it up, started playing with Jupyter notebooks way back in the day, 10, 20 years ago. And then as we started moving, we started addressing other problems. Do we need to have GPUs to be able to do that? Nowadays, I'd say yes to anything GPUs, but we had to learn on them. So we utilized some of the Jetson Nanos and the Jetson NXs to really start trying to teach us how to actually use these things and figure out how we can actually distribute. Can we answer a question before we have to even have that hardware come back to our home too, on top of that too? So addressing all of those problems one at a time was the way that we did it. Unfortunately, and now in today's time frame, you kind of have to answer multiple of those questions all at the same time as you're trying to progress through this. But at the end of the day, like you need, Matt was saying, is you need data. You need to have a reason to affect that data, and you need to figure out what type of result you want to have at the end of it.
The other thing that's a little bit more subtle is if there are these compute resources that are out there, they need to be marketed or advertised to the developer community within the organization. There's a term, bronet. You kind of ask a friend, hey, how did you do that thing? Oh, I called this guy, tell him I sent you, right? You go go knock 3 times on this door, right? He finds like, okay, here's the URL, but it's actually wrong, replace this, and like this is how you get to the cluster. It's like, okay, that doesn't really unlock the compute for the organization, but unfortunately can happen in many places. So I think a broad, marketing campaign or whatever about, the compute that somebody's invested in to that community so that it can be utilized and saturated. Because otherwise, I've seen, projects considered failures because nobody used them. But I was part of those same organizations, and had somebody told me that was there, I would have used the crap out of it.
Okay, Stephanie, go ahead.
Hi, can you hear me? So I have 2 questions. So my first one is related to data hygiene. So when we think about using large, dynamic, changing data sets, what are some techniques that organizations can use to ensure the continuous hygiene and cleanliness of those data sets? So that's the first part. Second part is bias. So when we think about using models or algorithms to inform human actions at the end, how do we account for any bias that may be in the algorithm up front?
Sure.
Thanks.
I guess we can similar to ping pong on this one. So the first part is how do I make data hygiene in general? To the extent you can instrument your systems, you get data that comes out fairly clean. They end up being machine logs that are structured or semi-structured in nature. That ends up being a really nice way to collect data at scale. And those data sets can change. I do realize that a production system can be upgraded, and sometimes the documentation team gets defunded and you have to make a hot fix, and then the logs change a little bit. But I think that's a good step in the right direction. And then probably building those ingestion pipelines and getting people to use those data sets will illuminate any weird oddities or maintainability issues. So those will be just kind of organically fall out. I think derived data sets, you probably want to know what transformations were done to that, so kind of maintain the data lineage. I've seen issues with time zones completely botching data sets, where I'm working with a team in Germany and a team in California and a team in Hawaii, and where somebody does a weird time zone normalization, and we're wondering why all the aircraft are in weird parts of the world and teleporting, and it just doesn't really make sense. So that's a specific example there. The biases can be a tough one, but as you start to become a mature data acquisition organization, you start to make sure that your data covers down on the right types of things. Some larger models, like these large language models, candidly, that's an open research area to understand all the ways in which it's biased. In the past, I've seen organizations. So before a lot of the low-code platforms, a lot of the data scientists, during a lot of my interviews, I would make sure that the people building the models understood the assumptions and constraints of those models and how bias would build up in those models based on the mathematics behind it. And you can make smarter decisions on the AI that you're using for the specific problem based on the assumptions and the fundamental mathematics. Now, as you abstract up layers and layers, and that can be abstracted away at times. So I encourage folks to endeavor, fairly robust test and evaluation routines where you throw a bunch of edge case at it, and you can kind of get a sense, a little bit anyway, of where you're kind of, at risk of certain kinds of biases.
Yeah, no, honestly, just from my perspective on the bias side, because I completely agree with you on the data hygiene side, when it comes to biases, you want to be able to know that one, there is going to be some level of bias, period. So you already know that there is going to be some form of that. So what can you do to potentially mitigate that? For instance, let's talk about malware in different regions. So if I pull out and I pull a sensor and I pull a bunch of data and I infer data, in all these different locations, everybody's going to have a different model. So we can use some techniques like distillation techniques to be able to start achieving some level where we're trying to figure out, hey, what is kind of the generalistic thought process behind that too? So it's kind of this weird thought of going, hey, I'm going to be really specific to these regions or these concepts of data, and then move it back out and then start looking at it from that perspective too, and then address it and trying to address it as best as possible when we're trying to deal with that as well.
There are other techniques that can expose a little bit more explainability in the kind of inference results. So this prediction was made because these features were in this combination and they were weighted in this way, to give you a little bit more intuition as to why that detection was made. That can really help in cases where you're launching a threat hunt and you want to know why this particular thing was anomalous. If this part of the law was strained for whatever reason, that could also help you uncover some things.
Great.
Thank you.
Okay, thank you for all of that. Sarah, thank you for putting together this panel. Wonderful job moderating it. So
thank
I
you.
Appreciate it. And to Adam and Matt, thank you for your insights and input. John Stressing in the back of the room, if you'd wave. John is the one who coordinated with Sarah to make this happen with the support of Allison. So thank you, Allison, as well. Gus is in the back. He is working the, the scanning. So if you'd like to be scanned, see Gus. I want to mention Parker Wood here in the front put together a wonderful reception that we're having this evening, hosting at Pickles Pub for the under 40 crowd. Or if you support under 40, I guess you can kind of come too. But certainly appreciate you all being here today. Thank you for your insights. Thank you for your support to AFCEA and to our emerging leaders. This is the future of our association, and you can tell we're in very good hands. Thank you very much.